Sawubona Mzansi, and welcome to the MIH Live. So we'll wait for a few people to get joining onto the lives. I see there's one viewer on Twitch, and is everything fine on YouTube? I think everything is fine on YouTube now. So how's it, Jay? Nice to see you here. We're just waiting for things to get started, and then we can continue. Hello, welcome to the MIH Live. Sawubona. So, thank you everyone for joining. So before we continue with the standard stuff of working on the MIH Studio, what I want to show you guys today is another content creator that I met up with today. And let me see if I can share. Yeah. So we had a nice discussion today, like a mini podcast vibe. So I'll flip my screen here for you on TikTok and you can see. So we had a mini podcast session, just he's starting up some sort of a podcast on his side and things are good. So please feel free to check him out. He is I Am Sislanda. You can check him out here on TikTok. Great conversations with him. Thank you so much, Jay, for the heart. Really appreciate it. So, yeah, so please, the conversations were great with him. Let me know if you would like to have him on the live one day. I can have a chat with him, and first check out the podcast. If you enjoy him, then we can get him on the live. So the first thing that I want to do today is take you through what we did yesterday. So let me switch this back. So in yesterday's live stream, what we were trying to do is we tried to get our new GPU working we tried to get our new GPU working on the MIH server. Right. So what we were doing were things like installing the drivers, making sure that they're working, making sure that they work specifically for Docker. That's another one that was a big issue on our side. And yesterday we ran out of time a little bit towards the end of the video. We were making good progress, but we ran out of time and we didn't get anything sorted. So what we did was we said we're going to continue working on it today offline. And that's what we did. So that was the progress yesterday. Yesterday, I think we managed to install the drivers. We could see that everything was working fine. And let me show you that now. So let me flip here and flip you on this side. So let me flip the people on TikTok. So if we have a look over here, let me know when you're able to see and if you can see. Yeah. So on this side, what we did was, I think it's sorry, I'm not typing. NVIDIA-SM something, SMI or something like that. Yeah, that was it. So this over here, this command that you're seeing on the screen right now is a command just to check if your NVIDIA drivers is working correctly. So if we have a look at the top of the screen, just over here, you can see that the driver version that we're using is 570. Our GPU is the NVIDIA GeForce RTX 4060. And basically, if this is up and running, that means that our computer has detected our driver correctly and everything should be working fine. So what we wanted to do yesterday was get it working with Docker, right? So in order to get it working with Docker, we ran into a little bit of issues. So I'll show you today that Docker is running fine. So we'll jump into what exactly Docker is in a few minutes. But if we run this command, you will see that it shows us that hello from Docker, right? This message shows that your installation appears to be working correctly. So that means Docker is working correctly. So why is that so important? Because Docker is basically the foundation of our MIH server. It's how we spin up all the different things like our hello from YouTube, like our database, our front end, our API layer, all of the different sections or all of the different components of MIH is what is there. Finally joined your session live. Thank you so much for joining. I appreciate the support. That was from YouTube, guys. So we are, for those on TikTok and on Twitch, we are live on TikTok. YouTube, and on Twitch. So on those 3 platforms, whatever platform you prefer to watch us on is where you can watch us. So as I was saying, we can see that Docker is running perfectly fine on the MIH server. However, the next step, what we have to do is what we were trying to do yesterday, is get our GPU working correctly with Docker. So even though if we're looking at, let me clear this, even though if we're looking at this message over here, everything seems to be working fine, but that is on the operating system level. That means that our operating system is communicating correctly with our driver itself, right? That's working fine. But in our use case, in between the operating system or on top of the operating system, we have Docker, which is the containerization tool. So we need Docker working with the operating system and with the GPU itself. So if we clear this, there is a tool. So we did the hello world. So Docker is running fine. So the next thing that we'll have to do is this command over here. So this command, you'll see there's GPU NVIDIA. It's basically running a little CUDA core or CUDA instance. That's NVIDIA's technology, a CUDA instance. And we're running the same command that we ran on the operating system level, but now we're running it from inside our container itself. So this is the big test to see that if our driver or if our GPU is being detected by Docker, which means that the Mzansi AI will be able to use the GPU itself. So we'll check if this is working fine and we'll see what happens. We click enter and you'll see we get the exact same message that we received before. So you see that we have the NVIDIA driver, we have it detected our GPU, and it was using that SMI. So that basically means that from inside our container of Docker, we are able to detect the GPU itself, right? So I know for the past couple of streams, I've been chatting about what exactly Docker is. And sorry if I miss your messages anyway, please just leave another message and then I'll get back to it. But I know I've been talking about Docker for quite some time now, quite a few lives, but today I think is the perfect time to get an understanding of what Docker is because it's a free technology. So are you running the app on a local server? So I don't know if local server is the correct wording to use, but it is running on our own server, on our own technology itself, right? Sorry, I did something here on TikTok that I don't know how to get back. Swipe up, swipe left to close. Sorry, I'm doing nonsense over here on TikTok. Give me 1 second. So yes, like I was saying, it's a good time to get into what exactly is Docker all about. What does it do? And just to get a little bit of understanding about it, swipe left to close. I don't know which way is left. Okay, sorry, I got it. I'm back. So you are asking, are you running the app on a local server? So yes, it is running inside the MIH studio. So that's where we are right now. So we have the server over here next to us running the MIH technology. So it is running in-house. We aren't using any AWS instances, or we are using any Azure stuff. So it's straight using our own technologies, using all the tools open and available to us. So the GPU will work in the hosting server. The GPU will work in the hosting server. I'm not sure how to answer that. But yes, so let's chat about Docker. So the first thing that I want to do, as we normally do in our lives, is ask Gemini to give us a brief understanding or a brief description of what exactly is Docker. So we will do that on our side. So you can see we are using Gemini 2.5 Flash. Even though it's experimental, it's one of their frontier models, but not the pro version. So we can ask it a question over here, what is, or please explain in an easy way, what is Docker? What is Docker? So we'll wait for it to think for a bit, and then we'll give it I'll play it for you so we can all hear what's happening. We'll give it some time. Let's play it now. Read. So it's thinking.
Okay, let's imagine you have a project, maybe a recipe you want to share with friends. Without Docker, it's like you write down the recipe, list the ingredients, and tell your friend how to cook it. But when your friend tries it, it doesn't taste the same. Maybe they used a slightly different oven, a different brand of flour, or their kitchen temperature is different. The recipe itself is correct, but the environment where it's being made is different, causing problems. Docker is like a special, standardized container for your recipe. Here's how it works. 1. You package your recipe, your application, and everything it needs to run into a special box called a Docker image. This box includes the recipe instructions, your code, all the specific ingredients, libraries and dependencies, the exact type of oven and tools needed, system tools and settings.
So I'll pause it there because the introduction that it gave us was, I think, was sufficient enough. I'll chat about it a little bit more. So basically, my understanding of what Docker is all about is, say I'm in a development team and I'm the first one of the team, and I set up my development environment locally on my laptop or desktop computer, my development machine itself. And now a new member joins the team, so now I need to get him or her up and running with their development environment. So I'll tell them, no, I'm using tool X, Y, and Z. All you have to do is install it. But the problem comes in when now I'm using version 5, but they downloaded version 8, and my application or the application that I'm working on only works with version 5. So now there's development or there's problems with the new developer because they're using different versions of the tool. So what Docker does is it allows me to create a Docker image, which is basically something that is shareable to anyone running the Docker technology. I can share it to my colleague, and then once they get the Docker container, they can run it, and they'll have the exact same development environment as me. So there's no differences. So I can just hand it over to them, and they'll be up and running. It's no install the software, and then getting into problems. All right? So another thing, let me switch the screens again. So let me know if that makes sense in the chat. And let me look at the chats. So the server has backup power in case of the power goes off. 100% currently at the moment. So there was a question on TikTok. So the server has a backup power in case the power goes off, because we are living in South Africa. Load shedding is a reality of our lives. So the current MIH server does have a backup power, but with the new MIH server that we have at the moment, because it has more power, it's drawing more energy itself. So we have to get a better backup power for the load shedding stuff that happens. Right? So I'll switch over. I'll flip my camera here on TikTok, and what I wanted to jump into this, visualize what Docker looks like. So I was Googling an image, and basically this is my understanding of Docker, right? So instead of you having the technology run directly on top of your operating system, or another case could be you have one server for your database, one server for your application layer, one server for your one server for your front end, all different servers for different applications, if you can call it that. What Docker does is it says on one operating system, on one server called the host, you can have multiple containers. So these containers can be different things. So instead of it having 3 applications, one can be a database layer, one can be the front end, one can be the API layer, right? And all of these containers can communicate with each other inside Docker itself. And another thing that is, sorry, I see there's a message. Have you considered using flooding of scaling in the event of more users engage, sign in or sign out in the platform? This flooding may overwhelm the servers. I'll make a note of that now. Thank you so much, Ernest, for the comment. I'll make a note of that now, and I'll dive deep into what exactly is flooding. Is it like a technology? Is it a tool? Is it a terminology, methodology? I'll dive into all of that to understand what this technology is and how it can assist us at MIH. So Yeah, so this is what Docker looks like, right? So if you think of it, the whole thing over here would be MIH. Inside MIH has the database, front end, and API layer, and they all communicate with each other. And then when you come into the one container itself, which is the front end container. That's the one that you look at when you're looking at the things. Let me know if there's any questions around what Docker is, how it works, or if you have any other questions. No, I mean in the event of a lot of users. So I get you. So I have to look in. We'll have to look into how to stop how to not overwhelm our server. That's the correct words. So we need to look at what technologies can we use to spin up the server, spin down it, or to increase it. I know that's one of the advantages of using AWS and Azure. It's like pay per use, and if there's an influx of users, you can just increase your pricing or your costing, and then it will be sorted for you. So we'll have to look at how how it will scale. So at the moment, I think the last time I checked, there was about 700 users, and this was using our old server, which had very old technology inside it. And it did scale pretty well, but I get what you're saying. When we reach the millions, how are we going to handle that? So we will investigate all of that to see how exactly we can prevent such a thing from happening in the future. Thank you so much, Ernest, for that comment on YouTube. So what I wanted to dive into now is chatting a little bit about Docker itself, because Docker is a free technology that you can use, and you can just go onto their website. We can just Google Docker. It'll take you to the website on how to install it, documentation, all of those kind of things. But what makes Docker so special and so useful to you is that if I'm a developer and I create a specific Docker instance or container or image, then all I have to do is, or I can submit that Docker container onto the Docker Hub, and then any person that is using the Docker technology or tool can pull that Docker image and have an instance of that container on their own hardware itself. So what exactly does that mean, right? So say, for example, I am looking at building a simple API server, right? So instead of me now going onto the internet and finding how exactly watching YouTube videos, reading documentation, all of those kind of things of how to create a fast API server, because that's one of the technologies that we can use in Python to create an API server. All you have to do is on the Docker Hub, you can search fast API. And when you do that, you'll just click on search. It'll give you a list of all the containers that are available for us to do with fast API, right? But the one that I look at most of the time is the ones that's by a verified publisher. What that means is this one was probably provided by the creators of Fast API or someone closely associated to the main development team in Fast API. And if we click on it and have a look at what exactly this is, it's basically, okay, there's not much information here, but it's basically you can pull this image. All you have to do is call this image name. It'll automatically download it for you, and it will spin up a fast API server for you automatically, ready to use, right? So it cuts out the development time or development and research time when working on big projects. So Docker is an amazing tool for that. Is there any questions around Docker? Let me have a look. No questions this side or that side. Perfect. So what I wanted to do today, let me go through my list. Okay, so now that is Docker, right? So when you're using just the main Docker tool, it's like a, how do I say it? It allows you to spin up one Docker image at a time. But we all know with big applications, there isn't only one application on your server. You don't only have a database. You don't only have a front end. There's multiple different technologies that need to work together to have that. So that would be in this image. So we have multiple different containers that we have working, right? So instead of me calling or starting up one container, starting up the next container, starting up the next container, I think like an offshoot or an advancement of Docker is called Docker Compose. So we'll ask Gemini, what is Docker Compose? Compose. What is Docker Compose? So we'll wait for it to think, and then I will play the audio for us when it's done thinking. So before we start it up, Docker allows you to easily create containers that is easily shareable amongst people, right? So now we'll understand what Docker Compose is all about. Is it playing? Read aloud. It's thinking, guys. Give it 1 second.
Okay, building on our recipe analogy for Docker. Imagine your project isn't just one recipe anymore. Maybe you have a website, one recipe, that needs a database to store information, another recipe, and maybe a separate service to send emails, a third recipe. Each of these needs its own kitchen with specific ingredients and tools, its own Docker container. Running each of these kitchens separately with just Docker can get complicated. You have to start each one individually, make sure they can talk to each other, and manage them all at once. Docker Compose is like a conductor for your orchestra of kitchens, containers. Here's the idea. 1. You write a special instruction sheet, a Docker Compose link to .yml file. This sheet lists all the different kitchens. Okay, so I think we can pause there because now it's diving into the details of how to create or how to use Docker Compose, all right? So just a recap. So what I was showcasing in the beginning of the live was, if we look at our terminal on the right-hand side of the screen, you see the command. Let's look at an easier command, docker run hello world, all right? So what this does is basically creates one of these containers for us, right? And yeah, it creates one of these containers for us. If we want to create another container, we're gonna have to run a different script like this in our terminal to create the second server or the second container. So what Docker Compose does is it gives us one command that we can run to create all our containers all at once, right? So that's basically what Docker Compose is. So MIH uses, let me flip the cameras for you. So MIH currently uses Docker Compose because, like I said, we have multiple different aspects. Like Gemini was saying, we don't only have one recipe for MIH, it's multiple recipes. We have database, all of these different things that we're spinning up. So we use Docker Compose. And because we're using Docker Compose, we also, if I go back to, let me flip this. So in the last live, I showed you that we were using Ollama for our Mzansi AI. So Ollama is another tool, and what makes it so easy and nice to use with Docker is, if I search Ollama, you see there's the tool itself. And you can see it's been downloaded over 10 plus million times. And this is the official one by Ollama themselves, created by Ollama. So this is their tool. So it's easy if you want to spin up your AI server, all you have to do is make sure that you have Docker installed. You come onto the Docker Hub and you'll use their tool. It even gives you command lines of how to use it. So you see the command on the side over here, which says Docker pull Ollama, right? Once you pull that, so if I were to copy this and if I were to paste it into my terminal, it would automatically create a Ollama server for us, right? No hassles at all. You don't even need to understand how they created the server. That's what the technology does for you. It hides all the technical stuff about how they created it. You just need to run one line in the terminal and then that's it. So here's what we are trying to do. So we want to use an NVIDIA GPU.
So we've installed the toolkit and all of those kind of things. So I want to ask Gemini specifically, how do we create, or how do I say this? How do I get this, or how do I get my Docker Compose instance of Ollama to start using the GPU, right? So that's what we're going to do today. Or that's what we're going to do now. Let me move this over, minimize it, and then we'll ask, I'll grab some code. I think the best way to, when you're working with AIs and things, is I like to give them as much context as possible. And when I do that, let me see if there's any secrets over here that shouldn't be revealed to you. I don't think so. Okay. So I like to give the AIs as much context as possible, because if you give them very little context, then they'll start hallucinating and talking about garbage. So let's flip our screens again. So how do I update this Docker Compose to enable GPU to be used with the Ollama container, and then I'll just paste it the Docker Compose code that I use to spin up the server, right? So I've sent it the question. We'll give it some time to think. And there's it over here. Let's listen to what Gemini has to say. Give it 1 second. It's thinking now.
To enable GPU usage for your Ollama container in your Docker Compose link to .yml, you need to add a deploy section to the Ollama service definition. This section allows you to specify resource reservations, including GPU access. Here's how you can update your Docker Compose link to .yml. Explanation of the changes. Version 3.8, explicitly setting the Compose file version is recommended. Deploy. This top-level key within the service definition is used for deployment.
So we can pause it, because now it's just breaking down what exactly did it put in over here and how is it different from ours. So the part that I think is important to us, everything seems the same at the top, is, and I do have this over here, I just didn't give it to it. It is this deploy section. So it's telling us over here, add the deploy section for GPU access, right? I'm trying to think, how can we do this without breaking things on my side? Or specify the number of GPUs. Okay. Reservation, NVIDIA. So, what's the time now? 1:30. So, or let's not do that. Instead of doing that, instead of updating it, let's just play around with Ollama first. Yeah, let's play around with Ollama first. So give me, just to test things out before we put it in MIH. So give me the Docker command to run an Ollama container that uses GPU. Right, we'll see what it says to us. So let me move this so I can see if there's any chats. So the server is on premises. It's a tricky situation. So I was looking at Kubernetes. So there was a question around, why didn't I use Kubernetes? Why am I using Docker? So Kubernetes is more, when I was doing some research before beginning my journey, Kubernetes was, or when I had when I was doing the investigations, it sounded like it was more for enterprise and big businesses and those kind of things, and they have more support for those kind of businesses rather than small startup businesses. So I didn't see much benefit from my side of using Kubernetes over Docker because in my mind they both do something very similar to creating containers for us to run our different things. So that's why I chose a Docker, and I heard a lot of people speaking about it in my previous company that I was working with, and just on YouTube when you're in like the coding YouTube of the world, people speak about Docker and stuff. So I wanted to try that out. So let's hear what this thing was saying.
To run an Ollama container that utilizes your GPU, you need to use the GPUs equals all flag in your Docker run command. This flag makes all available GPUs on your host machine accessible to the container. Before running the command, ensure you have the NVIDIA Container Toolkit installed if you are using an NVIDIA GPU. For other GPUs, you might need different drivers or toolkits depending on the vendor and your operating system. Here is the basic Docker command to run Ollama with GPU support.
Okay, so you can see in order for me to run, I'm not even using MIH's technology right now. It's just using Gemini itself. There's one line of code over here for us. All we have to do now is enter this line into our terminal or on our server, and we have a whole AI server ready for us to use. So we'll give it a try and see exactly what it's doing. Let me move the camera for you. Can everyone see? They should be able to see. So, like I said, we'll just paste that command in. And so you'll see the command over there. And then when I click enter, it should start downloading things for me and starting it up. If not, there's an error and we'll have to fix that. But let's see. So you can see unable to find image. So it's not finding the Ollama instance for me right now. So it's downloading everything that I need in order to run it correctly. So you see, I didn't have to do anything about getting my server up and running. It's all Docker. It's doing everything for me. You can see it's downloading majority of the files, which is 1.704 gigs, right? So this is the power of Docker. This is why we chose this one. I'm sure Kubernetes is very similar to this and is a competitor to Docker, but they are both powerful technologies. So we'll give it some time. It's at 600 megabytes right now. Sorry, let's check on TikTok to see if anyone was sending any messages. If you did send a message, send it again. I might have missed it. But if not, we all good then. We'll wait for it to download. It's almost there. So like I said, Docker does everything for you right now. You don't have to understand. You don't have to be a OpenAI or a whole Google company in order for you to have an AI server. That technology has now come to the people. And from yesterday's video, I'll just open a new tab for us. Oh, let's type this. Oh, llama. While that's downloading, if we downloads, back. While this is downloading for us, we can see that, we can look at the models. We can see that once we have a Ollama server up and running for us, there's multiple, I'll switch you over. So you can see everything ran successfully. So it looks like everything is fine right now. We'll check it up to see what's happening over there. But if you have an Ollama server running, then you have all of these AI LLMs ready for you to use, which is Gemma, Quinn 3. This is just the popular ones, DeepSeek R1, Llama 4, which was updated now 19 hours ago. If we have a look at this one over here, you'll see that the Ollama Docker version was updated 1 day ago. So all of these tools are being updated rapidly by all the different companies because technology is just moving that fast. So if we have a look over here, sorry, I'm going to open up my cheat sheet for Docker things. Docker cheat sheet. So this is the cheat sheet just to help you with the different commands of Docker. So I know one of the commands is, let's clear this. one of the commands is docker ps -- all, I think. Yeah. So these are the different containers that are running at the moment. It's a little bit confusing, but as you can see, there's Olama. Came up just a few minutes ago, and it looks like this one is up and running. Everything else, yeah, you can see over here, up. But everything else below that was just tests on my side. It was all the hello world stuff where it starts the container and then closes it immediately. So then, how Docker works is, or when you're creating some of the Docker files, is you tell it what operating system this container should have. So if we have a look at, I think I might have closed that image, but yeah, no, there's it over here. Yeah, so if you look at this image, each of these containers has their own operating system running inside it. So I can say that I want to have Ubuntu running over here, which is a version of Linux. Then I can have Windows running inside here. I don't know why you would have Windows, but I could have Windows running in this container. Then I could have Mac OS, for example, running in this container. It's just all examples. Most of the time you're using Linux because it's free, but you can have 3 different operating systems running specifically for the container, for the type of application that you are using. So going back to this, we can see that our Olama is running correctly. So what we're going to do now is we're going to use this command over here. So for my people on TikTok, we're going to use this command over here. So this command is basically docker execute. We want to go in interactive mode. So that's basically take me inside the container, right? And let me see what's happening inside the container. But you must remember there's no user interface for this. It's all black screens, just like this one over here on the left-hand side of the screen. And then SH is basically this black screen that we're looking at. It's telling me open it up using this black screen. So let's see how this goes, right? So we can say, let's clear this. So it is docker execute -it, the container name, damn it. I think it's Olama. And then SH. If we click on enter, now we're inside. So I know we were looking for something nice, big and flashy, but we're inside the container itself. If I use the commands, you can see pwd is show me what folder I'm currently in right now, right? ls, show me the list of all the folders and files inside this folder. So you can see we're sitting inside the Docker container. We are sitting inside, let me move this. We are sitting inside now this Docker container in the actual operating system that this Docker container uses, right? And once we're inside here, we can then open up the Olama thing and we can try use a bigger model over here right now and see what that works. But what this is telling me right now is everything has been done successfully. Everything that we worked on today, which was getting Docker up and running, getting Docker to see and use our GPU, getting the driver, so all of that has been working because there's no errors when using or creating this Olama instance. So let's see how do we run, or how do we, let's see the size of this, how do we add a Olama instance, right? So there is, I'm not gonna do a, should I do it? It's gonna take quite some time to download. How much time do we have? 40 minutes. Let's do the small one just to test it out to see how fast it does it. Because in the on the current MIH server, it's a little bit slow, but we can hook it up. So all we have to do is, like I said, all you have to do is we have our Olama server running, up and running right now. All you have to do is, now we're on Olama, I want to run this specific one over here. So I'll copy this code right over there. They even have a copy button for us. We'll take it to our Docker container. We'll paste it inside there. And we'll click enter, and then it should just run. Yeah, there's it over there. Now what it's doing is pulling our large language model. It's downloading the large language model for us. I don't know which is better to see. But it's down, it has our large language model. So it's downloading our large language model for us automatically. Zero effort on our side. You saw we created our own AI server, and we're now downloading a large language model that we can utilize. Even though it's a small one, it's just a test for now to see the speed at which our GPU works, or if our GPU works at all. So we'll give it some time. What it should do after pulling this is automatically take us to like a chat thing for us to just chat in this black screen to Gemma 3. Yeah, send a message. Can everyone see that? Send a message. Hello. Look at the speed, guys. There's it. Hello, how are you doing? Smiley face. Is there anything you would like to chat to us about? But remember, this is the 1 billion parameter model, right? And then I think, yeah, you can just say, I think buy or /buy, then it will go away. But this is it over here. Let me say buy /buy. Yeah, so we're out of it. Let's try and download, because that went really quickly. Let's try and download the 4 billion one. So how do we remove? So let's ask Gemini how to remove. How to delete LLM from Ollama. Sorry, it's on the side over here. Is there any questions for the guys at the moment? Is anyone interested? So, Ollama list. Okay, so here's all the LLMs that's currently running in this container instance. And it's basically just one at the moment, but we're going to remove that and try and get a bigger one. So all we have to do is Ollama RM for remove, and then the name of it is Gemma 3.1b, and it should just remove it for us. Deleted. Sorry, I can't do that. Ollama list, and we have no containers over here now. So what we'll do is we'll try a bigger model. So the one that I was thinking is the 4 billion parameter model, because our GPU is 8 gigs. So this one over here, if we have a look, it's 3 gigs to utilize it, or the size of this LLM is 3 gigs. And if we use this, and we can have 2 3 gig models that we can utilize. And I think from 1 billion to 4 billion, I think the intelligence does take a huge leap. So what we'll do is we'll just click on that command over here. We'll copy it, and we'll paste it in for you. So we'll paste it in, we'll run it. We will run it, and it will start downloading for us. So I'll flip the cameras, because I think this is going to take quite some time. I'll let you know when it's done. But we can have a chat right now and just see if anyone has any questions. So this is how easy it is to run your own large language model. You don't have to have an Azure instance that costs you thousands of money because you want a GPU inside it. You need your own hardware. If you have an old laptop at home, you can use the Docker technology, use the Ollama Docker image, and use the open source large language models on the Ollama website. Everything is accessible, is free for us to use. And going forward, I think that with our weak hardware that we have at the moment, the LLMs won't work as great as what we get online with our different tools. But think of a year from now, how efficient the large language models would be. So it's about halfway done downloading now. Let me know if you have any questions about LLMs or anything else. Maybe I can assist you with how this, or with whatever you have any questions about. I see there's 15 minutes left of our live session, but that's okay. We should get it. We should have the LLM ready for us. So this is the 4 gig one, guys. So let's go back here And I'll flip it over here on TikTok for us. Flip. So you'll see that it's 81% now. So it's 81% downloaded of. Please elaborate what RAG is. I can ask. Let's ask Gemini what RAG is. Please explain what RAG is. Please explain what RAG is in terms of LLMs. Sorry, I have no idea what RAG is. I know it as red, amber, and green for like Scrum stuff, but we'll listen to what it says over here. So let's wait for it. So our large language model has finished.
Retrieval Augmented Generation, RAG, is an AI framework designed to enhance the capabilities of large language models, LLMs, by providing them with access to external, up-to-date, and domain-specific information. Here's a breakdown of what RAG is and how it works with LLMs. What is RAG? Traditionally, LLMs generate responses based solely on the data they were trained on. While this training data is vast, it has limitations. Static knowledge. The knowledge is frozen at the time of training and does not include recent events or information. Lack of domain-specific knowledge. LLMs are typically trained on general text data and may not have in-depth knowledge of specific industries, internal company procedures, or specialized topics. Potential for hallucinations. Without access to verifiable facts, LLMs can sometimes generate incorrect or nonsensical information, known as hallucinations. RAG addresses these limitations by introducing a retrieval step before the generation step. It allows the LLM to look up relevant information from an external knowledge base and use that information to inform its response. How RAG works with LLMs. The RAG process typically involves two main stages. 1. Retrieval. When a user provides a query or prompt, the RAG system first analyzes it. It then uses this analysis to search for relevant documents or data snippets within a separate knowledge base. This knowledge base can be anything from a collection of internal company documents, databases, or even the internet. Advanced techniques, such as using vector databases and semantic search, are often employed to efficiently find the most relevant information based on the meaning of the query, not just keywords. The retriever fetches the top K most relevant pieces of information. 2. Augmentation and generation. The retrieved information is then augmented or added. Okay, thanks, Ernest. That's a great question that you just asked. So am I using something like this in the Mzansi AI? So when we first added the Mzansi AI to MIH, it was a proof of concept. Can I myself understand how to get a AI server up and running, which is what I showed you today. So that was the first part of our AI journey, just using out of the box, off the shelf technology without any customizations on it. So I think in order for us to use RAG, we have to have some sort of different implementation to it itself in order for it to work. And it looks like I have to have my own knowledge base. So I don't know if we can have access to Google's indexes, or so I'll have to like create my own index, and one day we will have all of that information inside MIH that we don't have to go look elsewhere. But I think on our journey, once we're first going to get the AI working with the GPU, after we update our server, get it working with the GPU, deploy that so everyone can use it and test it out. Thereafter, we can start customizing the Mzansi AI. I've heard about distilling before. I'm not sure exactly how that works, but that is it's training a smaller model based on a bigger model, right? So it gets all of that knowledge, gets distilled down to the smaller model. So we can look at how all of this kind of works, RAG stuff, just to make it a little bit smarter, and all of this kind of things we'll have access to. But that's something that we'll do in the future. And I don't think we should rush it. Just because the technology is there, we'll wait a bit. But thank you so much, Ernest. I'll make a note again on my side for RAG stuff for LLMs.
So RAGLLM, right? But if we have a look on the right hand side of our screen, I'll show you now on TikTok. So we're now back up and running in our now newer Gemma, I think it's Gemma 4 billion parameter model. So do you have any questions in the chat? So I think this will be fun if you ask me or type a message in the chat, and then we'll ask the Olama to or Gemma to assist us for this. So let's do the same question that Ernest asked. So please explain what RAG is in terms of LLMs and see if it comes anywhere close. We won't have the text to speech things, but I'm sure I can find the text to speech thing somewhere on the internet. Look at that speed, guys. Look at that speed. I love it. I love it. This is the speed that you're going to get in the Mzansi AI. Very soon you're going to get the speed. I love it. Worth the time and the struggle spent. So I'll copy this. Let's go to a text-to-speech generator or text-to-speech thing. Text-to-speech AI. We'll use one that's not an ad. Speech to text, text to speech. So let's copy all of this over. Please explain. Okay. Guys, did you witness that speed? You witnessed it live with me right now. The speed of the new Mzansi AI is going to be just as fast. So you're witnessing it in real time right now, how quick it's going to be. So let's hear what Mzansi AI has to say. Yeah, I see we definitely use too much words over here. But let's do the intro and see. If we do the introduction, play. Let's see if we can hear what it says.
Okay, let's break down RAG, Retrieval Augmented Generation, in the context of large language models, LLMs, like GPT-3, BARD, or Claude. It's become a hugely popular and effective technique for improving the performance and reliability of these models.
Okay. So sorry, this thing over here doesn't give us much things, but you can see it's on track. I'll copy one more block of text over here. I'll paste it in, and it's still too much. Let's cut this. Still too much. Cut this. Yeah. Let's play. So you can see that Gemini gave us what RAG is.
The problem with vanilla LLMs. LLMs are trained on massive data sets. LLMs like GPT-4 are trained on a huge amount of text data scraped from the internet. This gives them incredible general knowledge and the ability to generate human-like text. Lack of specific knowledge and context. However, because they're trained on the entire internet, they don't inherently know specific up-to-date information. They also struggle with.
Okay, so to me it feels like it's on the right track with what Gemini is speaking about, right? We weren't able to hear the whole thing. As you can see over here, it's quite a huge, large text. So in the Mzansi AI, I told it specifically, don't tell me long stories, get to the point when you're answering questions, or else you're going to hear all this long stuff from the Mzansi AI. But it looks like, okay, in short, RAG is a smart. Let's do this one over here. So it's copy. It's like the conclusion of everything.
In short, RAG is a smart way to enhance LLMs by giving them access to external knowledge, making them more reliable, accurate, and adaptable to specific tasks and domains.
Okay, I think I forgot to remove the with. But you can see that in this hour session that I was with you, let me flip the cameras. In this session that is about an hour right now, we created our own large language model server that is currently running one of the top open source models out there, which is not the very top, but one of the top, which is Gemma 3. And Gemma 3, we got it up and running, and we're using our GPU, which you saw the speed, how fast it is. And you saw how fast it is. And you see, there's no cost over here at all. I didn't have to hit up Microsoft and say, please give me a server, I'll give you 50 Rand a month or something. And 50 Rand a month going on forever is a lot of money, right? So if you have all the hardware, you can use Docker, Ollama, the Ollama image from Docker, use Ollama to pull the large language models. And I think, Ernest, on your point about RAG stuff with my LLM is Ollama gives you the capability to modify or customize or have your own LLM available. I don't have to pull Google's LLM. I can use theirs, modify it, create my own version of it, my own customized version of it, and run that inside the Ollama server. That'll all be done. That we can all do ourselves for free, right? So for those that just joined, so it looks like we got through our list successful today. There was no issues. I love it. I love it where things run smoothly and things are going our way. So it looks like, so today we showcased that Docker was working. What Docker is. Sorry, TikTok is telling me something about which of these objects is a handle or has a handle. They're telling me that if I'm a robot or not, imagine. Okay, it's done. So today we showcased that Docker was working on the new MIH server, that the drivers for our new GPU is working on the new MIH server. Docker is able to use the GPU that we just installed in our new MIH server, right? And we tested out, we created an Ollama instance or an Ollama container using Docker to see if there is a difference between the speed of the Mzansi AI. And I can even show you that quickly towards the end of the chat. I'll show you the speed difference between it. But yeah, we created our own LLM server. I showed you how to do that. And we've tested it out with our GPU, and we saw the speed difference. So before we close off, let's check out the speed difference with the current, and even the hallucinations of the current. I'll ask it the same question that Ernest was asking. So let's copy it. If we paste it and send. So do you see the difference in speed of what we had before and the current Mzansi AI? So this is why we wanted to get a GPU and why we updated our MIH server. Because look how slow this responded to me in the same amount of time, but there was maybe 4 times the amount of text available too, or that it provided to us. Right? So that's the reason why we are updating the MIH server, to provide you with a better experience and a more reliable experience when using the Mzansi AI. And we are aligning ourselves to create our own version, having our own RAG stuff with our own data set and all of those kind of things. So thank you so much once again, everyone, for joining the live today. It was wonderful. There was no issues, no worries. We have everything up and running. So tomorrow morning, I am ready to move. So I'll post another video tomorrow, maybe tomorrow morning, about how the live went. And then I'm not sure if you've seen this before, but at the bottom of the TikTok videos, I have it's like an event thing for lives, but it gets hidden up because I use the caption stuff. But you can click on that and then set up reminders for the live on the videos if you want to watch the lives and see what we're getting up to and the progress that we're making on the MIH server. But thank you so much once again, and let's keep working hard, Mzansi.